Into Theorem 1 of grade 12 that says the following. If I have any line, one of those three sides of the triangle, and I have a line parallel to it, now it can even be interior or exterior, we'll get to that. When I have parallel lines, then I know that top over bottom is top over bottom. Now you'll have to squish your head a little bit to the one side to be able to see top, bottom, or whichever side you chose to use it, but the ratios are in proportion. What are we busy with? Ratio and proportion. So that's the theorem. Let's have a look at the question that I gave you. The question said, find F and find G. So which one would I have to find first? And which has that scenario? F, definitely F. So if I want F, no, not F. Can I find F? Yes, I'm sorry, I watched it wrong. It's definitely F, you are right. To find F, I'm using which triangle? AFG. And I'd like you to say that. In triangle AFG, what happens? We have the scenario that we have to have, namely that BE is parallel to FG. That's important because it was given. And that can and cannot be with them all. So if it's parallel to each other, then I can say F over 36, come guys, wake up. F over 36 is the same as 32 over 48. That's it. No, there was a reason why I said that. The theorem says line parallel to one side of a triangle will do what? Divide the other two sides proportionally, or in the same ratio. To find F, then it's just a sum that you've got to go do, namely that over that times with 36. What does it give me, please?
24.
Does it have to be a whole number, or could it be a fraction?
Yes.
Could be a fraction in any given sum. So this is then 24. Now I can find G by working in which triangle?
A, B, C.
A, B, C. If you're looking for that scenario, you need a triangle. So basically, you're ignoring that parallel line. You're looking at it like, that's the top, that's the bottom. There's top and bottom that you're looking at, for instance. So can you then find G? So it's going to be G over the whole thing, which is 80. And then it will be 30 over the whole thing, which is 60. You've got it. But please don't just write that. Please don't just say G over 80 is the same as 30 over 60. And you get your answer, G is equal to 40. Fantastic, you're right. But you've got 1 out of 3 marks for this last bit. Because you needed to tell me that in triangle ABC we have DE parallel to BC. No, sorry, I'm wrong. Sorry. You're busy with the bottom one, right? FG is parallel to BC. We're ignoring that. So if FC and BC are parallel, then it's G over 80 and 30 over 60. So that was also given. Now say for instance you started off the sum and wrote here all the parallel lines, that would be perfect. Not a problem, you've written it somewhere. Most of the time it's not worth a mark specifically, but since you're always talking about parallel lines, you should be telling me where they are. Maybe you had to prove that they're parallel first before you could get to this answer. So, and am I now going to get full marks?
No, you have to write
The reason, yeah, for saying that is again
line
to one side of a triangle. Even if it's 14 times in one sum, you have to give a reason for every time you use that theorem. Right, then we are looking at number 6 together. I'm going to give you a minute or two just to think about it, and then we're going to mark it.
Wait.
Okay, let's have a look at the sum. It asks me for y. Please don't just write. Where did you start? Y over
4.
4 would be the same as 2,5 over.
2y plus 1.
Is that the only way to write it? Definitely not, because you could have started with 4 over y. It would have been 2y plus 1 over 2,5. Remember that these are ratios. And all the stuff that you used to do in your equations, you can still do. You can flip them both. You can cross them eventually, which we are going to do. Are you with me? So, but usually we want the y at the top. It didn't matter if this one was at the top. They're both going to have to come to the top in the next step. But what is majorly wrong here? I just jump into the sum. I'm going to get marks, but not all of them. I need to tell them that TC is parallel to EM because it was given. So that I have my go ahead to say line parallel to one side of a triangle. Are you with me? Then you're in line. Now you can do the math, which you're going to do by cross multiplication. So we've got 2y squared plus y is equal to
10.
Happiness on that? What happened here? I immediately, because I don't have space, said y times the 2y plus 1 gave me 2y squared plus y equal to 4 times 2.5 is 10. Then to solve this, what type of a sum is this?
Quadratic.
Quadratic. So you have to say,
Could have just said quadratic.
and then you've got to factorize that, or you can use your fancy calculator to find the factors. Please give me the answers. Is y is equal to 2 or
Y equals 2
Negative 5 over 2.
negative 5 over 2. That your calculator would give you if you said a is 2, b is 1, c is negative 10 in the equation function to find your roots. Those are your roots. Please don't write x. Okay? Then this should have been y plus 2, and this should have been 2y plus 5 equal to 0. Okay, so when you're factorizing, you can do it any which way.
One up down.
Why is this? Oh, sorry, thank you. So factorizing, going backwards, crooking it right. I didn't crook it right, so I would have lost them off. Maybe they would have not seen it. I hope so. Okay, but going back, it should have been y minus. There should have been 2y plus the 5. And double check. When you time it out, you do get back to that trinomial. So then why are you saying that y is equal to 2 and not equal to negative? It's a distance. That's why. The algebra is perfect. No reason why y cannot be negative 5 over 2. But the practicality of it is I'm trying to find a distance there. That's why that cannot be. And that's all you need to do. Also not applicable. So the distance of y is definitely 2. You could have then gone and said, in other words, if this is then 2, this would have been 4 plus 1, right? Which is 5. Do you see the ratio is 2 to 4, which is 1 to 2. This is also 1 to 2. Stays the same, has to be. And that was it. Can this be a matric question paper?
Yes.
Definitely. That's your level 1 sums. You can just use the rule, use the theorem, and you've got it. So number 7 is for homework. Now let's have a look at number 7, just to help you so that you are on track when you try it. Information has been shared. This was all written down there. They said to me that AB is 2 centimeters, BC is 3 centimeters, CD is 1 centimeter, and 4 centimeters. This was not on the sketch. I had to write it in there. Now when you write it, nitty-gritty stuff. You don't have to put the centimeters everywhere. It's fine. But the fact of the matter is those are lengths. These are lengths with centimeters. But 1 to 2 is a ratio. And the ratio 1 to 2 stays constant. So please remember, when I put there that the ratio is, say for instance, the ratio here is 4 to 5, does that mean 4 centimeters and 5 centimeters?
Not necessarily.
Those are just ratios. Are you with me? We're going to get to sums like that. Then I want you to be careful not to write 4 and 5 there. I'd rather say 4x and 5x. This is completely not on this sum. I'm just stressing the fact, if I told you that the proportional ratio here was 4 to 5, it's not 4 units and 5 units. It's 4 times something, I don't know. Just like here, it was 2 and 4, so it was 2 times 1, 1 times 2 and 2 times 2 for the ratio 1 to 2. Okay, just for later. But the main thing about this sum is that they want me to prove, after telling me that these two lines are parallel, they want me to prove that DG, I'm going to make it red, and CA are parallel as well. So we're going to need, sorry for that skew line, we're going to need to use a converse here. Now what would be the converse? I'm throwing you in the deep end. The converse would be when I tell you 2 to 4 and 2, 5 to 5. What would you deduct? That AB is parallel to CB. When you can see that the ratios are the same, the lengths are not the same, but the ratios are the same, what are you going to deduct? You're going to say, look at this one, it's 2 over 4, which is a half. Look at that one, it's 2, 5 over 5, which is a half. Aha! So the ratio, top over bottom, is equal to top over bottom. And after saying that, you can say, therefore, the lines are parallel. And what would be your reason?
Converse.
Converse of line parallel to one side. You're getting the line parallel, but you say converse of theorem number 1. Are you with me here? That's where I'm going. So can I help you a little bit more? Where do we start? The given part was parallel lines. So you must search. That's why color helps you a lot. So if you color it, well, I'm going to keep it blue. But the blue scenario is top and bottom, top and bottom. Are you with me here? With the parallel lines, top, bottom. So this should also be
Top, bottom.
top and bottom, which is going to give me 2 and 2. But be careful. What did I say?
You said 4x. You said 3.
I said it's not 2 and 3. You must say it.
X.
Because it's not 2 and it's not 3. It's a ratio. The ratio is 2 to 3. This is actually 2 centimeters and 3 centimeters, but that can be 4 and 6. Are you with me? But there's something else in this sum that was given, that otherwise I wouldn't be able to carry on. They told me that AF is the same as FE. Does it look like that on my sketch? Definitely not. AF, FE, ma'am, something's wrong here. Sketches are not drawn according to scale. Remember that, even if it doesn't look like that. But now we've just said that this is 2x and 3x. What does it help me?
So that's 5x.
That's 5x, the sum. Although it's horrible to look at, but this is the same. This will also then be 5x. Reason? Because it's been given. Okay, but it's ratios, right? It's not actual lengths. Let's get back to the bottom now. If we want to prove this red scenario is parallel to each other, do you see the red triangle starting at E, going to the red line where? G. And then going to A. Are you seeing the scenario? In the red parallel situation, from the top point of the triangle to G you must go, then to A. What is that ratio?
8 to 2.
Ratio 8 to 2. What is the ratio here?
4 to 1.
The same.
Oh.
Because 8 to 2 is 4 to 1. That's what I was writing here. You're going to have to write. Okay, look, marker. That over that is 8 over 2, which is 4 over 1. Look, marker, this has been given 4 over 1. What am I seeing? Those ratios are
the same.
equal. What's the deduction? Lines are parallel because reason?
Converse of
You got
lines.
it. Now we'll just see when we mark it if you get all the marks that you should be getting. Right.
Oh, that's easy.